Alright, now that we've had outputs, let's try and check out an input. An input is something we can control from the external part, and it will try to figure out whether we've pressed something, whether we've altered the power on something. It will make sure that it knows. So first of all, we're gonna try and connect our button, because that will be our input. And once that is connected, we can use it to control an LED light. I will press this in here and make sure that it is very tightly on my little breadboard. Oh, the pins have collapsed. Are you pressing against that? No, you shouldn't be. Try to put it nice in the middle. If your breadboard is not cooperating, that is fine. Just come to me and ask if I can help you with that. But you will need your buttons to fit in there. I should have done this in advance, but I could. Anyway, so let's put them over here so that they're nice and visible and separated from each other. Okay, so that's in there, it's fine. Okay, so we've got a button on our breadboard. And now I can wire it up. Now, last time we did this, we just used a little LED and we let the power run through the LED. Now we want to do something different, because I can say, all right, I can, for example, in my code say, if I press the button, turn on the LED, but we've done that we've done that in a circuit, and that obviously makes it way easier. But what if I want to change it around? What if I say, okay, now I want you to make sure that the LED isn't on when I press the button. That's all of a sudden way more difficult. Or, for example, I want you to turn on the LED when I press the button and then turn it off the second time you press it. That also makes it way more difficult. So what we're first gonna do is make sure that we can revert the process. If we click the button, then the LED should be off. So that means that at some point we will also need a little LED. I can already put that on there, and I basically also can use the same schematic I've done last time. I connect it to button 15, and I can plug this in through the positive one. And now I'm gonna do something different from last time. I'm gonna use the resistor on the negative leg, which is all just in line with the same technique. That means that if I plug it from the back end, the flow of current through my LED is still restricted through that resistor. So it doesn't matter if I put it before the LED or after. What you can also see is that my Raspberry Pico is still flashing. The code that we write and we put on our Raspberry Pico will remain there always. That means that when you plug it in and it has power, it will run the code that you've last uploaded on it. All right, so keep that in mind. Secondly, if it's unpowered and I power it back on, then the same code will remain on it. It will keep it stored in its memory, and it should be able to run it back again. Did I make a mistake? I may have made a mistake. It's no longer connected as well. That is a bit weird. I think my last code I tried was not valid. I will check. No, it is valid. I just cannot do this. Okay. Anyway, I have written new code and I've done it on there. Just know that the code you write is on there, but you cannot get it back off. It's always on there. Now, I've connected the LED. I will now share the little coding screen instead of my face. And we can write the same code as last time. So I can say, okay, I've got an LED. I'm going to write this in capitals because it's a constant value. I will not change it throughout my script. And I can say, okay, it remains in pin 15 and it is an output pin. Again, mind you, you do not have to learn only by using these clips. You can also look some stuff up on by yourself. This code will always be the same. What we've also seen last time is that we can use a little loop while true. Sorry, this is without capital. While true, And then within this loop, we can say, okay, I want this LED to, for example, toggle, and I want it to be about a second long. So sleep between 2 cycles. Okay, so now it comes in, it says, all right, this LED variable is on pin 15 and it is an output pin, so you will send power through it, and then it's gonna check, okay, while true, this means it's a loop. I want to toggle this, so if it's off, turn it on, and then I want to sleep for a second, and then I start over again. Is it off? Then turn it on, or vice versa, and then I sleep again. So this was our output, is the same code as last time. Slightly different, but it's the same gist. What I now want to do is I want to add my button. And what I want to do specifically with my button is I want to make sure that if I click it, that I know that it is wired up correctly. It's the same with the LED. You just sometimes want to know for sure that whatever you've wired up is done so correctly. And we're first going to make a little mistake. I'm going to start with giving it some power, because if I want to measure the power output, then at first I need to put some power in as well. And then I can connect the diagonal side, like the other side on the diagonal, to my Raspberry Pico. It's orange, that's going to be very confusing in a second, so I'm going to use a different color for the second pin. So on the diagonal, I take another one and I put it here. So now this might be connected, but I will never know. What I want to do is I want in my code put a little if statement that says, if this button, I'm going to first put it in comment, if the button is pressed, I'll print something. It's just a note to myself. So now I can start adding it. I can say, okay, I've got a button, it's on pin. This is guessable code, what we call it. And it is an input pin. We've added this in our functions. Now I can say if the button value, and now it's a function, equals true or equals 1, then I want to do something. I want to print, for example, button pressed. Else, if that isn't the case, I don't want to do anything, so I can just leave that out. But I can say, okay, I want to print button not pressed. Okay, so now a lot is gonna happen, but now none of the right things. So now if I press it, it's gonna say, okay, it's pressed. If I release it, it's gonna remain pressed. That is weird. No, it is not. It has a very logical reason. First of all, let's get rid of this little sleep sign here. And from the LED toggle, we will use the LED to say, okay, if I press the button, I want the light to be on, value 1. Otherwise, I want the light to be off. The main issue here is an electrical thing. You can see this button is going all over the place and it doesn't know whether I press it or not. Why is that? That is because most of the time this is an unclosed circuit. So there is no power on the plus if I do not press the button. And that goes through the wire, and that is what they call a floating pin. Floating pins are never fun. You should always try to avoid these. So what we want to do is we want to add a little resistor to make sure that the flow that's coming in from the plus can go back to the minus if necessary. Hup. And now all of a sudden my button responds exactly as I configured it. There is something going on in the comments, but that's okay. Just turn that one away and run it again. Oh, it's still getting the messages in because it has been so much. I'm just gonna unplug this. There we go. Okay, so if it's too much messages, it obviously gets a little confused. So now I can update it, and if I press it, the light goes on, and if I release it, the light goes off. Now, what's the fun part about it is we can now solve our challenge. Now I can say, well, if the button isn't pressed, turn the LED on. If I press it, turn it off. This little switch would have been very hard if we worked only with circuits. But now that we work with code, it makes it way easier to just swap some things around. Even better to do is we actually have on this breadboard two different circuits. We've got one for the button, we can completely disconnect from the LED and vice versa. So why not do this in our code as well? What if I just say, okay, I'm keeping a little variable saying button pressed. I just say, okay, the button dot value, we store this in this variable. And that means that if I now say, okay, if the button pressed is true, then the LED should be on. This may seem like extra work and unnecessary, but at the same time, this makes sure that if we want to do other actions with the same button value, that it's separated. It also means that I can now start commenting it out way better. Store button status. This little extra resistor, by the way, just makes sure that if power is coming in through the plus and the button isn't pressed, that we can relay it over the resistor back to the ground. Why a resistor? Because this power will try to find the shortest path or the best path of least resistance whenever possible. So if this would just be a wire, then the power would always go through the resistor. It would never go through the blue wire, so never to our pin, so we wouldn't know if anything is pressed. This is a pull down configuration. Always use it when you're using buttons. That's an easy match. Just always make sure that you're using this configuration, right? So that means that your button will always work flawlessly. If your button is doing something weird, or it's not working, or it's it seems like it's relying on the movement or the board or whatever, you just know you've probably forgotten a resistor there. So if we try to draw this circuit, by the way, which I will try to do now, then we have from our plus, we have one wire that's going through the button, so that is this, and it's going towards our ground, in this case pin 14. So power sent through will go to pin 14. Not only this, it's also when the button is not pressed, we have this situation. So this is the ground. So we have a circuit that goes through the ground but over a resistor, and then when we press this down, there's also power going through 14. But because this resistance is harder than the pin of 14, most of the power will use this. It's the same with water. If this is a small pipe and this is a big hose, but we've cut it, then it will go through the small pipe. But if the big hose is open, then most of the water will just go through here. There will some go away there, but most of it will come through here. So that's one circuit. The second circuit that we've made is just starting from the same plus. Sorry, it doesn't start from the plus. It starts from the minus. So this is wrong. We basically added a second one that starts from 15, goes through the LED, goes through resistor, and ends in the ground. So those two circuits are present on this board. And because they're separate, if something breaks, it doesn't matter. I have the second circuit, which I can, none of the other circuits will have issues. So keep that in mind. Keep in separate circuits, and don't forget to add the little resistor for the ground. I will keep this up closer to the camera if somebody wants to replicate it. Try to follow along with these courses and try to see if you're stuck somewhere. If you're stuck somewhere, obviously send me a Teams message or an email.